The title of my presentation is Biohacking with Nutrigenomics, a systems approach to nutrigenomics, wellness, and aging. This may be the single most important health presentation of your life. I call it the Biohacker's Guide to Wellness and Aging. I need to make an FDA disclaimer that I do not make claims to treat, cure, diagnose, or mitigate disease. This is purely informational. As you may already be aware, nutrigenomics is the science of how food-derived and nutritional products affect our gene expression. Remember, food is more than just calories and nutrition. It also acts as a code for our body's cells and our instruction set in our DNA. In my previous talks, we discussed about how it is better to make antioxidants and chemical substances than our body needs than to take them externally. We can do this by signaling various pathways in our genetic instruction set to turn on mechanisms to increase these necessary life-giving substances. This is the difference between cellular activation versus supplementation. There are currently three mechanisms by which we can activate our body's genetic signaling system. The first is the NRF2 signaling system, which is a mechanism by which we can reduce our oxidative stress levels by increasing the number of internal antioxidants so that we can reduce our oxidative stress by 40% within 30 days and 70% within 4 months. This is an incredible feat by itself, but not to stop there. The second method by which we can activate our body is called the NRF1 signaling pathway, where we can increase the ability to support our mitochondria's production and rejuvenation so that we can have more energy and metabolism for the necessary energy that our body needs in order to not only maintain, but to heal itself. And lastly, the third method by which we can activate our body is called the NAD and sirtuin system of activation. It is also related to the information theory of aging, which I'm going to discuss in great detail in this talk. This talk will primarily be about the NAD sirtuin theory of aging. The other subjects are covered in 2 other separate lectures that I give on these subjects. When we signal these genetic pathways in our DNA code, it's essentially like flipping a switch. We do that so we can feel better and that we can do more. You know, articles are all around these days in the major publications that suggest that our genetic code potentially would allow us to live as many as 140 years if we didn't suffer from disease. We're actually genetically programmed to live a very long time, but it's the process of aging that affects us all. And so we are very interested in what it takes in order to live not only a longer lifespan, but a longer health span. Dr. David Sinclair recently addressed the concepts of aging in his recent book, Lifespan: Why We Age and Why We Don't Have to. It's a fascinating read, but very technical. I'm going to try to break down some of the major concepts and show how it applies to the science of gene activation that we're going to talk about today. The unifying theory in aging is that we may suffer from information loss as we get older. When it's talked about in this way, we call it the information theory of aging. Our DNA is such a capable information storage vehicle. All of the world's data could be stored in one room if it was put into a DNA molecule. Our genetic instruction set is actually a form of digital storage, but instead of being made up of digital ones and zeros though, it's actually made up of 4 letters: C, G, A, and T. These are the first letters of the chemical base pairs that make up DNA, and therefore our DNA is a base 4 system of storage. It provides for infinite storage and is inherently stable. DNA has been replicated time and time again over millions of years with rarely a mistake. Where the problem lies is in our epigenome. Epi means above the genome. The epigenome is inherently unstable because it is not digital, it is analog. It has to be analog so that our bodies can respond to our environment and our situations. It allows us to change on the fly. This allows us to adapt, but it's also our Achilles heel. The epigenome can be added to or subtracted from with exposure to the environment and with time. This then affects how our genes are expressed. In essence, our environment can signal our genes to either turn on or turn off. This is why we say that only 20% of our genes are active at any given time, and the rest lie dormant. It's a lot like a DVD disc. The disc on the right is brand new and has all of the digital information and can be read very clearly. However, look at the DVD disc on the left. It's all scratched up. The information is still there, but it's been affected by the environment and with age, and now the information's not readable. Those environmental changes were analog, but the data on the disc was digital. So it's the same with our genetic code. So how does the surface of the disc, or our epigenome, get damaged? Well, that damage is caused by our exposures to UV light, toxins, free radicals, and oxidative stress. This chemical damage essentially scratches our genetic code or even cuts it in places. The same thing is happening to our mitochondria that we use for energy. This is one reason why we want to reduce our oxidative stress and also help our mitochondria. But let's go deeper on this dive with this concept of epigenetic damage. If you look more closely at the chromosome above, you would actually find out that it consists of a twisted double DNA strand that is wrapped around some small protein spools that are very tightly packed into a fiber that's called chromatin. This is what actually makes up the chromosomes. Taking an even closer look, some of these tiny protein spools, which are called histones, have chemical tags on them. They're marked in red on this diagram. These tags are placed by enzymes in our bodies and also as a result of our environment. In some cases, the tags are permanent and can't be removed. The more we have of these permanent tags on our DNA, the older we are. These can actually be measured and can allow us to test our body's apparent age, even if we are older or younger. When some temporary tags are present, the genes unwind and the code can be read. These are active genes. When the tags are removed, the DNA is more tightly packed and the code can't be read. These are inactive genes. The active genes are on the top, the inactive genes are on the bottom. In some cases, we don't want genes to be read because they weren't meant to be reactivated. If they were to be reactivated, the body would age quicker. This is where sirtuins come in. The letter SIR in sirtuins means silent information regulator. They help to keep the tags off so that the genes will be packed more closely and not read. They also help to repair DNA damage. If they are always busy repairing damage by oxidative stress, then they can't do their job silencing the genes that are not supposed to be active. And this causes us to use up valuable fuel and resources and causes us to age faster. The more permanent tags, though, act like a brake in the railroad tracks and prevent the DNA from being read by the train that is coming by. Essentially, the train has to stop dead in its tracks. So let's look at all the important jobs that sirtuin proteins do for us. It's very deep. Just pay attention to how long the list is, and just get some of the info. Some of the other words you may or may not recognize. Not all of this is important for you to digest. Just get a feel, okay? Repair DNA damage. Removal of tags. Protect telomeres. Mitochondrial function. Autophagy or cell cleanup. Protein synthesis. Reduce stem cell depletion. Tumor suppression. Decrease inflammation. And finally, improve insulin sensitivity. These are just a few. That's a lot, isn't it? So in essence, sirtuins are a protein that act like a buffer pad for our scratched or damaged DVD with its genetic code. They are the cellular guardian and housekeeper for us, sort of a CEO. They restore the surface, they help get rid of the noise and scratches, they restore the defects or tags and regulate how well the disk, which is our genetic information, is read. But doesn't a buffer pad need some buffing compound or polish for the pad to be effective? Well, NAD is the polish that sirtuins need. It's the cofactor that is required for sirtuins to do all of that work. NAD stands for nicotinamide adenine dinucleotide, but we'll say NAD for now on, and not NAD. Now, NAD is not just important for sirtuins, but it's also important for other longevity genes and enzymes too. These include mTOR, which is responsible for the balance between building and tearing down things in our bodies, and also AMPK, which helps our metabolism and glucose and insulin regulation. As an aside, all of these regulatory genes are also affected by our eating habits and our environmental stress levels. So what have we learned so far? Let's simplify all of this amazing information about how our wonderful bodies work. It is amazing, isn't it, how involved all of these mechanisms are? But for our purposes, it's just background for the simple things that we're getting to. Don't freak out. Let's review. We have genetic damage due to oxidative stress and the environment. Damage causes information loss, aging, and poor function. Sirtuin proteins repair damage. Sirtuin proteins do a lot of good things to protect us. Sirtuin proteins absolutely need to have NAD to do their work. NAD is the key cofactor for other anti-aging mechanisms also. We want to increase sirtuin protein activity and NAD in order to be healthy and to live a long health span. Bottom line, sirtuins and NAD are good. We need more. How can we increase sirtuin protein activity? Caloric restriction and intermittent fasting convince our body that we're in a period of stress and that we need to be in preservation mode. This increases sirtuins. Exercise that stresses us and makes us breathe hard increases sirtuins. Temperature extremes of cold and heat also push our body and cause sirtuins to increase. So some of these are good, but many, such as caloric restriction, are not sustainable by many of us to use them just to increase our sirtuins. Fortunately, nutrigenomic activation of NAD genes also increases sirtuins, and it's far easier and more reliable. The natural history of NAD is that it declines steadily with age, and the sirtuins also decline to about 40% by the time we're 50. And 90 to 98% by the time we're 80. Without NAD, we're dead. We must have it. Sirtuins must have it. NAD is found in every living cell. If a cell doesn't have a source of NAD, it will die within 30 seconds. The left side of the screen shows what I said before about exercise, dietary changes, and NAD activators being ways to increase sirtuins. How much NAD you have depends on how much you can produce versus how much you're using up doing the daily chores of the body. We can either make NAD from scratch, which takes energy and time, or we also have what's called a salvage pathway, which allows us to make NAD from used parts. This is faster and more efficient than starting from scratch. Some of the precursors or parts that make up NAD are NR, nicotinamide riboside, and NMN, nicotinic mononucleotide. All of the steps are run by enzymes, which tend to be the limiting thing, as there is plenty of spare parts around, although having some extra spare parts doesn't hurt and helps a little bit. Here is a diagram of how NR becomes NMN, which then finally becomes NAD. NR is on the far right, and NAD is on the far left. We are going from right to left in this drawing. It's like a conveyor belt at a factory. As I said, the red arrows point to the enzymes, which are the rate-limiting steps. It takes 2 steps to get from NR on the right to NAD on the left, and only 1 step to get from NMN in the middle to NAD on the left. We can pile on a bunch of extra NR on the right, but this doesn't help it get converted any faster, especially if the enzyme just runs the conveyor belt at the same old pace. NMN is a bit closer to the finished product on the left, but this still has to be processed by the last enzyme to get it to the final product of NAD. What NAD signaling does is to turn on the two enzyme steps and make the system work faster and better, and then it can convert the spare parts into the desired product, NAD. This bar graph illustrates that caloric restriction on the left light blue bar increased sirtuin levels by a respectable 94%. When our competitors tried to use NR to try to make more NAD, it only increased sirtuin activity by 2% in 72 hours. Up to this point, it was the only way to get a bump in NAD without caloric restriction and stressing the body. But when we used our NAD synergizer, which signals the two enzymes to become more active, the increase was a whopping 100% increase in sirtuin activity in just 24 hours. It was even better than caloric restriction, which increased sirtuin levels, but remember, you had to calorically restrict your diet to get that 94%, and that's not very fun, and it's hard to do for most people. Who needs to figure out all of this diagram to be healthier? Especially when we could have the latest in biohacking technology with Protandim NAD Synergizer. These research scientists figured out all of this stuff so that we don't have to. We can still eat healthfully without starving ourselves, we can exercise and go to the gym as usual, and we can partake of saunas, steam rooms, and cold plunges, all in an effort to increase our sirtuins. But we can go even farther now by taking a nutrigenomic activator to replace caloric restriction or intermittent fasting. So what's the net result when we take Protandim NAD Synergizer? First and foremost, it doubles sirtuin activity within 24 hours. We get a boost in mental and physical energy. We get improved mood and motivation, and we get improved mental focus and concentration. We support the removal of cellular waste. We support healthy DNA function. You remember the scratched DVD and the polish? We maintain healthy cholesterol levels already in the normal range, and we also support a healthy inflammatory response. Remember those other systems that we said NAD supported? We also support a healthy vascular system. So remember that this Protandim NAD Synergizer is part 3 of a 3-part system of activating cellular pathways. It's synergistic, or working together with the NRF2 Synergizer and the NRF1 Synergizer. This is by design. So a quick review. NRF2 on the left is the cleanup crew. It's your cellular firefighter and sanitation department to clean up damage and put out fires and inflammation due to oxidative stress and free radical damage. NRF1 in the middle is like the energy company. It fires up the powerhouse of the cell, the mitochondria, which is in all of our cells to produce energy that's needed for life. And finally, NAD on the right, it's the Cell Executive Officer, or CEO. It tells the cells what to do. It directs, it distributes energy, it mobilizes and utilizes fats, it cleans out the debris and helps replace bad cells, it repairs our genetic material. In essence, it sort of acts like a parent. When NAD is depleted, it's like your parent is depleted. Nothing gets done around the house. The hamper doesn't get emptied, and the dirty clothes pile up. Okay, I want to make a few final points before I finish. You've learned a lot, but now for the icing on the cake. If each of those things does such a good job, what happens when you take them together rather than individually? Well, NRF1 in the middle is activated 69% more with all 3 synergizers present than when NRF1 is used alone. NRF2 on the left is activated to levels that nobody has ever seen in the history of nutrigenomics, to the tune of a whopping 1,563% above the baseline use of NRF2 alone. Just think of what kind of reductions of oxidative stress are occurring now. Further research studies are underway to further document this and to patent this tri-synergizer effect. And I gotta tell you, I cannot wait to see that report. And finally, NAD is increased by 1,792%. I mean, shut my mouth, right? That's ridiculous. Look at the two enzymes that were the ones that were involved in the NAD salvage pathway again. That conveyor belt is running fast, not slow now. Can you imagine the effect that this will have on sirtuin levels and the other longevity genes that we need in order to have a longer health span? That's what all the talk is about. Here it is, the now patent-pending Tri-Synergizer in pack or bottle form. This is why we're so excited. Remember, the Vitality Stack is a biohacking starter kit that won the Bronze Stevie Award in 2018 for the best new health product in the international market. But it's missing the NAD Synergizer. You have to add it separately, and many people do. I expect that this will be redesigned in the future. But for now, it is being sold like this with added prebiotic in a kit which LifeVantage is calling the Ultimate Stack. I think this is a good way to go, and it's personally what I'm doing because it covers all bases. It's essentially the Vitality Stack with NRF2, NRF1, a probiotic, omega-3s plus vitamin D, the NAD Tri-Synergizer, and a prebiotic. So I want to leave you with a super exciting video clip that puts this all together.